If you look around yourself, you can see many things, such as this screen, chair, fan, plants, maybe water also. There are also things that you can't see but can definitely feel, such as air when the fan is switched on, or air in a balloon. All these things, which are made of some material, are called matter. Let's look at the matter in our surroundings to understand it better. Imagine this table is the universe. Does this universe have matter? Yes, I can see some books, a water bottle, a pencil, and a balloon too. These things take up some space on the table. Now, what if the table wasn't there? These things still take up some space. Not just this, water occupies some space in the bottle. Air occupies some space in the balloon. And air is also occupying the space around all these objects. This is the first property of matter, that matter occupies space. But how much space does it occupy? Now look at this glass with coffee. It is this long and this wide. Similarly, look at this lunchbox. When we measure its length, width, and height, we can determine the amount of space that it occupies. This space is nothing but the volume of the object. But is volume enough to describe matter? This orange and the stone are of same shape and size and occupy the same volume. If you hold the two in your hand, you'll find that the stone is heavier than the orange. Therefore, matter also has mass. Overall, matter is anything that occupies space and has mass. For a very long time, scientists thought of this question. What is matter like? Is it like this wooden block, a single continuous object with no space inside? Or is it made of smaller units? Maybe think of water. Is it like this continuous thing? Or is it made of some smaller units? Now imagine that matter is actually like this wooden block and water is like a continuous object. That means if we put something in water, the water will have to shift upwards to make space for this object. So its level should increase. Now the same should happen if we add salt or sugar to water. Again, the level of water should increase. Now let's try this. Now, in this experiment, you will need a glass of water and something to mark the level of water. I am sticking this triangle. You can also mark it with a pen. Now, take a spoon of some salt or sugar and add it to the water and mix it till it dissolves completely. What do you think will happen to the level of water? Would it remain the same as before, or will it increase? We see that the level of water is the same as before. Interestingly, the level of water doesn't change. So where did the salt go? The salt now occupies the space within water. This means that water is made up of smaller units known as particles. And there is space between these water particles that now the salt particles occupy. However, in the previous case of the stone, the space between water particles is not enough that the stone can occupy this space. We see that water is made up of smaller units which are known as particles. You must be thinking, are these particles big or small? Let's first imagine that the particles of matter are big. Imagine that we add very little color to a glass of water. You can't see the particles of the ink, but you can tell their presence through the color of the solution. Now we take about 1/5 of this solution and add it to a new glass and fill the rest of the glass with clear water. Now when I do this, maybe one or no particle would be present in this new glass. If you repeat this again, you will probably get water with no particle, and the water would be clear. Now let's imagine that the particles of matter are small. Again, if I add very little color to a glass of water and take out 1/5 of this solution, add it to a new glass and fill the rest with clear water, what I find is that many particles of color are still present in the new glass. If you repeat this again and again, you will again get water with some particles in it, and the water would not be clear. Now let's try this on our own. Now for this experiment, take a glass of water with some ink or food coloring in it. I have made this scale on a paper and pasted it onto all the glasses so that I know how much water I am taking out or adding. Now take 1/5 of the colored solution and add it to the empty glass next to it. Now fill the rest of the glass with clear water till the marking. The color of this solution is lighter than the previous one. Repeat the same process using the next empty glass. This solution is even lighter. Now this process is also known as dilution. Repeat the same step for the fourth glass. Now does this fourth solution look clear as water? Let's check. Now here on the right I have clear water with no ink. To see if there is any ink particle still present in the glass on the left, keep a white sheet and compare the two glasses. The glass on the left still has very little blue tinge. We find that these particles are actually very tiny, and we will need to repeat this process few more times to get completely clear water.